Welcome to this explainer. Okay, if your company is pouring millions into enterprise AI and getting, well, completely mediocre results, you absolutely need to pay close attention to this. Today, we're unpacking a massive paradigm shift from a groundbreaking Medium article that is going to completely change how you view large language models. Because if you've been working with Retrieval-Augmented Generation, or RAG systems as you probably know them, you know they're pitched as this magic bullet for unlocking internal knowledge bases. But as you've likely experienced, there's a colossal roadblock getting in the way.
So, let's just ask the million-dollar elephant in the room question that literally every engineering team and CTO is quietly sweating over right now. Why do these incredibly expensive enterprise RAG systems fail so often? I mean, you connect a brilliant retriever to your Confluent spaces, your wikis, your policy docs, and yet the AI constantly hallucinates, misses the point entirely, or surfaces completely irrelevant information. It is beyond infuriating, right?
Well, get ready for a bit of a bombshell insight. It is actually not the model's fault. It's your human-first writing. The documentation that your teams have spent years and years crafting is actually the villain of this story. It's literally breaking the machine. I know, that sounds wildly counterintuitive to say that good writing is bad for AI, but it completely validates the frustration you've been feeling. We're feeding narrative, human-centric text into a system that simply does not read like a human.
Okay, let's dive into this with Section 1. Why your RAG fails. The human-first illusion.
Think about it like this. When human beings read documentation, we read linearly. If you're on page 3 of a manual, you implicitly carry the context of pages 1 and 2 right in your head. Our documents are written assuming the reader already has that context. But retrieval systems, they completely lack that context. They extract isolated, tiny chunks of text and try to map them to a user's query. If the context isn't explicitly written inside that specific, isolated chunk, the machine is totally blind to it.
Listen to this core, definitive industry truth straight from the source article. Most enterprise RAG failures are caused by documentation quality and not model quality. It makes perfect sense. If information wasn't clearly expressed and properly structured in the source text to begin with, a retrieval system cannot magically recover it out of thin air. At its core, this is fundamentally a documentation problem, not a retrieval engineering problem.
Let's look under the hood in Section 2, how retrieval actually breaks, the mechanics of failure.
The author identifies 3 primary failure modes when RAG systems ingest unoptimized text. Those are semantic fragmentation, context loss, and low signal density. Let's rapidly break these down so you can mentally categorize exactly what's going wrong in your own systems before we learn how to fix it.
First up, we have semantic fragmentation. You can think of fixed token chunking exactly like a paper shredder. Most RAG pipelines split documents by a totally arbitrary token count. Because our human documents lack clear structural boundaries, this mechanical shredder just cuts straight across logical concepts. A crucial procedural step gets severed from its prerequisites, leaving the AI completely blind to the full picture. It's a mess!
Then we have the second issue, context loss. Imagine an isolated text chunk starts with the sentence, "It should be configured as follows." Now, to a human who just read the previous paragraph, it is obvious. But to an AI looking at this chunk in total isolation, it means absolutely nothing. When pronouns, implicit references, and unexplained acronyms are isolated from their surrounding text, their embedding vector becomes highly ambiguous.
All right, turning the corner here with Section 3, the upstream fix, the key insight. The simple, undeniable truth to fixing your AI is this. Better RAG starts upstream with how the documentation is actually written. This is the secret sauce that enterprise companies are missing right now. We have to stop trying to engineer complex, expensive band-aids. Every single section of your documentation must be self-contained, explicit, and semantically complete.
And this quote brilliantly illustrates our main philosophy. Retrieval quality is determined before indexing. Think about that. No matter how advanced your embedding model is, it absolutely cannot compensate for poorly structured source text. You can tweak algorithms all day long, but at the end of the day, garbage in will always equal garbage out.
So how do we actually do this? Section 4, Writing for Machines, the blueprint.
Here are the zero-fluff, highly actionable rules that will instantly upgrade your internal knowledge bases. Step 1, one concept per section. Don't mix what a system is with how to deploy it. Separate them out so chunks map cleanly. Step 2, self-contained text. No pronouns referring to past sections, ever. Every sentence must stand completely alone. Step 3, descriptive headings. Headings like Overview are entirely useless to a machine, but a heading like Authentication Token Lifecycle, that acts as a perfect, high-density retrieval signal.
Moving on to step 4, consistent terminology. If you call a tool an OMS in one paragraph and order system in the next, you are just going to confuse the AI. The machine will scatter the concept across different clusters. Pick one term and stick to it. And finally, step 5. Use atomic steps and explicit metadata. One action per sentence makes it incredibly easy for the AI to grasp an instruction.
To summarize this entire philosophy, you really just need to remember this punchy equation. Better writing leads to better retrieval, which leads to better AI systems. It is a direct, unbreakable chain.
Let's look at the proof. Section 5, the transformation, before and after.
Now, what's really interesting about this comparison is the stark contrast. Compare the unoptimized narrative text, which uses vague language like it validates the payload, it retries up to 3 times, against the RAG-optimized structured text. The model has no idea what it is in the unoptimized version, but the RAG-optimized text replaces those vague pronouns with explicit system names. The order intake service receives and validates. This completely fixes the ambiguity because the subject is baked into every single chunk.
Here's another incredibly common trap. Look at the verbose policy document compared against the RAG-optimized table. The policy document is just paragraphs of legal fluff causing low signal density. But transformed into a machine-friendly table? Zero filler, just clean data. A 35-token table with clearly labeled facts will absolutely dominate a 400-token paragraph in precision retrieval every single time.
And we definitely can't forget metadata. Adding simple, structured metadata headers to your documents, things like document type, system, and owner, is a massive, massive game changer. You instantly transform messy, hopeful semantic searches into highly precise, filtered retrieval. You're no longer just hoping the AI finds the needle in the haystack. You are handing it the exact GPS coordinates.
Which leaves us with one critical question. Is your company's documentation actually ready for AI? If your enterprise tools are underperforming, it is time to stop writing for humans and start writing for machines. To get the full, deep dive methodology behind this framework, you absolutely need to go read the viral source article on Medium. This thing is everywhere right now, and for good reason. And frankly, if your enterprise needs an expert to architect this exact transformation and save your massive AI investments before it's too late, reach out to the author directly to hire them. Trust me, it'll be worth every penny. Thanks so much for joining me on this explainer, and I'll catch you next time.